So back in 2008, the entire global financial system pretty much stared into the abyss. And in the chaos that followed, one huge question kept coming up. How do we stop this from ever happening again? Turns out the answer might not be in some new set of rules, but in fixing the very tools that were supposed to protect us in the first place. Today, we're digging into the battle over finance's crystal ball.
We all know the story, right? Reckless bankers, crazy complex financial products. But what if the real problem was hiding in plain sight? What if the very mathematical models that were designed to be the tripwire, the alarm system, were actually the system's biggest weakness?
After the crash, the blame game was intense. And right at the heart of it were these things called quantitative risk models, these super complex formulas that were supposed to see disaster coming, but they just didn't. They failed spectacularly. And everyone wanted to know why.
To really get what's going on here, we have to rewind a bit. Back in the 90s, JP Morgan comes up with this tool called Value at Risk, or VaR. It spread like wildfire and became the standard for pretty much everyone. Then, of course, 2008 happens, and VaR just completely breaks down. That failure kicks off this huge search for something better, and it basically sets up a title fight between the old champion, VaR, and a new contender, Bayesian inference.
So first up in the ring, we have the reigning champ, Value at Risk, or VaR. For decades, this was the go-to tool. If you were a bank or a regulator and you wanted to know how much risk you were in, you used VaR.
So what is this thing really? Well, VaR's big promise was simplicity. It tried to take all the chaos and complexity of the financial markets and boil it all down to just one single number. It answers a simple-sounding question. On a really bad day, how bad could it get? It might tell a bank manager, hey, we're 95% sure we won't lose more than $10 million tomorrow.
Okay, so this number, negative 3.7 million bucks, this is a real VaR calculation from the paper we're looking at. But here's the really dangerous part. This number isn't the absolute worst-case scenario. It's the we're 95% confident number, which means there is still a 5% chance of losing way more than that. And what happened in 2008? Well, the entire financial system found out exactly what horrors live inside that little 5% tail risk.
So after VaR just spectacularly face-planted, the hunt was on for something smarter, something more flexible, and that's when the challenger steps into the ring, Bayesian inference.
The whole idea behind Bayesian methods is learning. You start with what you think you know, an initial assumption, maybe an expert's hunch. They call it a prior belief. Then, as new data, new evidence comes rolling in, the model updates that belief. It's basically a mathematical way of doing what we all do every day, changing our minds when we get new information.
And this slide, this really gets to the heart of the difference. It's like two totally different philosophies. VaR is kind of a historian. It just looks at the past and says, well, the future's probably going to look like that. A Bayesian model is more like a detective. It looks at the old evidence, sure, but it's always looking for new clues and bringing in expert intuition to build a better theory of what's going to happen next.
So we have this big fight, right? VaR, the history buff, versus Bayesian, the flexible learner. But what if this whole debate is missing the point? What if the problem isn't which model you choose, but the fact that you're putting all your faith in any single model to begin with?
And this is where the paper's author, Dr. Yogesh Malhotra, comes in and says we're all asking the wrong question. He argues that the real fight isn't VaR versus Bayesian. The real focus needs to be on something he calls model risk management, because the biggest danger of all is our blind trust in any one model to give us the right answer.
And this is the true villain of the story, model risk. It's the simple but incredibly dangerous fact that every single model is just a simplification of a really messy, complex world. It's the risk that the map you're using is just wrong, and it's leading you to drive right off a cliff, all while you're feeling perfectly safe and secure.
Here's a really simple way to think about it. Financial models are basically just weather forecasts. Some, like VaR, look at historical weather patterns. Others, like the Bayesian approach, bring in satellite data and expert meteorologists. But we all know that no single weather forecast is ever 100% right. A smart pilot doesn't just check one weather app before taking off, right? No way. They look at multiple forecasts to understand the range of what might happen and get a feel for how uncertain things really are.
So, okay, this sounds good in theory, but how does this actually work in the real world? Well, the paper doesn't just leave us with a theory. It actually lays like a practical step-by-step framework and then applies it to a real-life situation.
The method is called Empirical Model Risk Management, and it's a really simple 3-step process. Step 1, use a bunch of different models, not just one. Step 2, compare what they all say. And Step 3, and this is the big aha moment, measure the gap between their answers. That disagreement? That's not a problem you need to solve. That is the answer. It's a direct measurement of your model risk.
And just to prove this wasn't some academic exercise, the author took this exact method and stress-tested it on a real, massive $500 billion portfolio from a top Wall Street investment bank. So this is the real deal. And here are the results. They took 4 different, totally valid models and ran them on the exact same $500 billion portfolio. And just look at the difference. One model says the monthly risk is about $2.7 million, but another one says the risk is over $5.7 million. That is not a small difference. That's a $3 million gap in what the expert models are telling you.
And that disagreement, that's the whole point. It shows you, plain as day, that no single number tells the whole story. The real risk isn't 2.7 million, and it's not 5.7 million. The real risk is the deep uncertainty represented by that entire range. That $3 million gap is your model risk, and it's a risk that is completely invisible if you just pick one model and blindly trust it.
So what this all leads to is a pretty profound takeaway. This whole quest to find the one single perfect model to predict the future, it's a fool's errand. The smartest way to manage risk isn't about finding the one right answer. It's about embracing the fact that there are many answers, and then working to understand the limits and the blind spots of all of them.
And that leaves us with one final, kind of unsettling question. Maybe the real lesson from 2008 isn't that our models were bad or wrong. Maybe our biggest risk wasn't the models themselves, but our own blind faith in them.